Welcome to Wickerson Studios. I'm taking a look at a rhinoscriptsyntax as RS script. I've just made it a little exciting. As the curve comes out, I put it through a variable pipe, which runs through a rain and a graph mapper and caps my points. That's just so I can do something a little fancy and have fun with these little curves, make it a little more interesting to look at. But the script is what we want to get into, and it runs as an import rhinoscriptsyntax as RS and importing math. So I'm not going to import Rhino yet. You bring it a point list, and I'm going to take this up. And you really don't have to worry about what's after it, just focus on the top part. You have points coming in as a blank list. And for I in range n, so I can change n, which is the number of how many points there are, I can generate this curve. I will iterate through n, and x will be generated by a formula that I really enjoy with a couple of multiplying factors, scale x and scale y, very interesting. And z is just the iteration times scale z, so it just goes up and down. It's kind of nice as a geometric shape. And then I take the points and I use the rhinoscriptsyntax as add point. You can add x, y, z because that's a function that has some information tucked into it. You'll see that as we get on to Rhino comment. Basically, after you use that function, rhinoscriptsyntax add point, you can set your points and append it by those points, and then create your curve from rhinoscriptsyntax, another function, add interp curve points. Now that's fairly limiting. Like, it's nice that it does for you and it's a nice script. You don't really have to get into understanding it too much. But what I want to show is how I end up making that into a Rhino, taking it off rhinoscriptsyntax and using the Rhino import. And you could import this Rhino you could bring it in as Rhino geometry, because that's the main namespace I'm using as RG. And I'll show you how we end up playing with this. Set the points, and when you get to a point of where you have to switch it over, you can see here that I switch over the rhinoscriptsyntax add point down to here, rhinoscriptsyntax point 3D add. But it requires two different things. It requires point and vector. So initially I go in here, and I'll show you exactly what I do. I end up typing in here, and since we have the rhinoscriptsyntax now sent to RG, I'll show you what I'll type in. Point equals RG dot point, and I scan down to 3D because that's what I'm dealing with, dot add dot. And when I get to add and I don't want to add another dot, I'll hit a semicolon and it says, you're going to need, as I jump in here, a 3D point and a vector, which means I have to create those things. I can't assume the function's doing that for me. So I'm going to leave that blank and say, well, if it wants a point and a vector, I better go in here and I better generate a point first. So I'm going to go back up here and say, well, I can't use that point, but I'll generate a point using Rhino geometry, point 3D. Make sure you type it right. And that's going to say you need a float x, float y, and float z. So you could just type in x, y, z. And that takes care of my point, which means I won't need this one right now because that's a function that runs on Rhino script, but I still require a vector. So let's take a vector and let's generate equals Rhino geometry dot vector, vector 3D dot, and what am I doing? I'm creating a vector 3D, so it will ask me for what I want, and it will want 3 floats, so I can use my x, y, z again. Now I've generated the vector, the point, and so that should run nicely, and now I can input my point and my vector into my function. It's not a function, it's actually just a script line. So I'm going to say, okay, well, you couldn't assume all that. You couldn't just type that and then switch it over to some type of add point and add x, y, z. You had to generate that vector and point from that in order to add it in. So that's a great way to understand that. Down here is much more interesting to go in here and say, okay, I want to do that again. Let's create a Rhino geometry curve, but you can't just create a curve. You have to go into what is really used well in Rhino, which is NURBS, curves. Now NURBS curves are interesting because you end up having to use another dot to create one. So this gets a little more complex, and it takes a little while to get this. And when you hit that, it's going to say you're going to want a periodic Boolean saying, do you want it open or closed? So I'm going to say false or closed. Degree I can set to a slider, which I did within my grasshopper. I set my degree to integer from 1 to 5, and you'll see how I have better play and more. I mean, your functions, your grasshopper scripts become much more versatile and can do more if you're writing Rhino Common as opposed to RhinoScript. This is a great example to see why you want to do this. And it is self-taught. It's very hard to find online somebody teaching you this, and it just keeps pointing you to Rhino Developer until you end up learning how to read all of this data that's coming out of the bottom. So I'll try and leave that up as we get to this NURBS curve. And so it's going to want false for periodic, not false to periodic. Degree is actually slid in there as a slider, and the points that are being worked are the points. Now that should allow me, if I run it, to generate, what did I do wrong? RS is not defined. Oh, I forgot to take off my Rhino script because I don't need it anymore. And if I run it, there we go. It changes a little bit of the shape because it's doing more. But as we go in here and see it functioning now in Rhino geometry, it's a wonderful thing because I can change it back to degree 1, which is something I couldn't have done using the interp curve. I'd have to put it in as polyline, retype another script because there's different functions for different things, and I can go all the way up to 5, 4, 3, 2, 1 as polylines, and I also have a better understanding of what I'm actually scripting. It shows you that you're actually using a little more logic and math and algorithms in how you're actually constructing things. So I hope you found that beneficial, and I just basically showed an example of moving from rhinoscriptsyntax into Rhino geometry as RG. And I'll continue to do this through very simple iterations through this entire textbook. Thanks for watching.